Welcome back. The objective of this video is to compare different kinds of mathematical models, and we'll also write the equation of a parabola. So again, we've got another data set here, our x's and y's, which we'll input into our calculator, and then we'll use our calculator to come up with a linear model, a quadratic model, a cubic model. We'll determine which one best fits the data, and then we'll make a prediction based on that particular data. So let's go ahead and input the data into our graphing calculator, and we'll get underway. So with my calculator out, I'll go into the Stat menu. We're going to edit, and we'll edit our old lists. I've already cleared list 1. I'm going to cursor over to list 2. I'll clear that guy and hit enter, and then we'll go ahead and input our x's into list 1 and our y's into list 2. Again, making a note of our x's and y's so we can use that to reset our window. So I put my x's into list 1, 0, 5, 10, 15, and 20, and I'll put my y's into list 2, 10.2, 2.9, 8.2, 16.1, and 17.9. So I'll probably have a y window somewhere between 0 and 20 or 0 and 25 when I set my window. So my y's are all input. I look and double check. Now I'll go over to my window. My x's I set between -5 and 30 so I can see my y-axis, and I counted by 5s. And my y's I set between -5 and 25, so that allows me to see my x-axis, and I counted also by 5s. So we'll go ahead and graph our data, and there's our scatter plot of our data set. So now we want to go ahead and find a linear model, a quadratic model, and a cubic model using the skills we learned in our last video. So I enter Stat, Calc. We'll start with our linear regression. We're going to use our lists 1 and 2, and we calculate our linear regression of our slope is 0.572, our y-intercept is 0.534, and we'll transfer that information over to our answer key. And we'll also put it in our calculator under the y equals, so we can graph that line and see what that looks like. So my linear model's y hat equals 0.572x plus 0.534, and I'll also put that under the y equals menu in my calculator. Now I'm going to go back and do that again, and we'll get a quadratic model. So Stat, Calc, 5 is our quadratic regression. Use those same lists, and now our quadratic regression, our a value in ax squared plus bx plus c is 0.0594, and we have 0.617 and 8.311 for our b value, and now I'll go ahead and write those down on our notes. So we got 2 down, write that in our notes, and 1 more to go, our cubic model. Back to our calculator, and Stat, Calc, cubic, looks like that's 6. We're using our same lists, lots of enters, and now we have a cubic function with a, b, c, and d, and we'll record all that information, write that down on the side. There's probably a way to get this right into y equals, but I'm going to write it down and I'll put that in separately. So I've recorded the cubic model with the correct a, b, c, and d values, and I put those different models, the cubic, the quadratic, and the linear, into our graphing calculator. And we'll select each one of those so it graphs simultaneously with our best fitting line. It'll graph in our same window. So we can go ahead and graph that, and I have an error somewhere. I used the wrong negative sign here in my cubic model on the A term. So we'll try it again. And wow, that blue one, that cubic model looks really good. It goes through all of the data. So that's the one we're going to want to use. So our answer to question D, which model is the best? As we saw, the cubic model is best as it passes through all the data points. So we want to use our best fit model to predict when we have the value of y when x is 25. This is why we did a little bit larger window. So now we can use the value function in our calculator. And so we can go to second calc, value, and I've got all my functions here. It's telling me it's going to use the cubic function. That's the one I want. And we get a y value of 3.319. So f of 25 equals 3.319 using the cubic model. Example 5 says a parabola contains 3 different points. Find the equation of this parabola in standard form. Well, each of these points is an x and a y. And the standard form of a parabola is going to be y equals ax squared plus bx plus c. And since we have 3 different points and 3 different x's and y's, we're going to use 3 different equations and solve a system of 3 equations in 3 variables to solve for a, b, and c. So what that looks like, I'll show you here in just a minute. But we'll use point 1 and put the x's in. -1 will go in for x, and then y will be our 3, and so forth. So I'll set that up for you. So we have 3 points, so we end up with 3 equations. So I'm substituting from point 1, I'm substituting -1 in for x and 3 in for y. So I get a times -1 squared plus b times -1 plus c equals 3. And point 2, I get a times 2 squared plus b times 2 plus c equals -3, our y value. And the third equation, we have a times 3 squared plus b times 3 plus c equals a y value of 3. Simplifying each equation, equation 1 simplifies to a minus b plus c equals 3. Equation 2, 4a plus 2b plus c equals -3. And equation 3 is 9a plus 3b plus c equals 3. So now we need to take 2 of the equations and drop out one of the variables a, b, or c, and we'll have to do that twice and we'll have to do it to the same variable. So let's take equations 1 and 2 and we'll drop out the c's. So we'll show you what that looks like over here. So I'm going to take equation 2 and I'm going to subtract equation 1 from it. So equation 2 minus equation 1 is going to drop out my c values. So I get 4a minus a gives me 3a. I get 2b plus b is going to give me 3b. And positive c and negative c are going to drop out, and I get -3 plus another -3 equals a -6. So now I have a new equation that's in 2 variables, a and b. In fact, in this one I can even simplify this, dividing it by 3, and I can get a plus b equals -2. So now I have a new equation in 2 variables. So now I need another equation in 2 variables of a and b. So I'm going to drop out c again, and I'm going to use equations, looks like I'm going to use equations 2 and 3 and drop out c again. So if I multiply equation 2 by -1 and add it to equation 3, that's the same thing as subtracting 2 from 3. And I get a -4a plus 9a leaves me with 5a. I get a -2b plus 3b leaves me with a positive b. Negative c plus c drops out, and 3 plus 3 equals 6. So I have 5a plus b equals 6. And I have a plus b equals -2. So I'm going to take that other equation and I'm going to subtract that. So if I subtract the blue equation, the a plus b equals -2, I get a -a. So that gives me 4a equals 8. And then I know that a is equal to 2. So now I have one of my variables. Well, if a is equal to 2 and a plus b is equal to -2, so -2 plus b equals, oh pardon me, that'd be a positive 2 plus b equals -2, then b has to equal -4. So now I've got an a value of 2, I've got a b value of -4, so now all I need to do is calculate c. So if I use equation 1, here, well, so I have 2 minus a minus 4, a minus b plus c equals 3, I get a value c equals -3. So I have an ordered triple of 2, -4, -3, and I can substitute into our standard form, and I get 2x squared minus 4x minus 3 is the equation of our parabola. And we'll get some more practice with this when I see you in class.